This video showcases an example of differentiating an exponential function within a different function. Check it out here in differential calculus. The problem requires the derivative of the function y, which is equal to e raised to 3x all over 1 plus arctangent of x. Since the equation is simplified, there is no chance to use logarithmic or exponential rules, or even trigonometric identities. So we better tackle it directly using the quotient rule. This procedure requires the square of the denominator, where the numerator starts with the lower term multiplied by the derivative of the upper term. Then subtract the upper term with the derivative of the lower term. Now just focus on those d's, where the first term has the derivative of e raised to 3x. This is an exponential derivative, which can be taken as just e raised to u, with the derivative of u upon the derivative of x by virtue of chain rule. U is taken as 3x. Du all over dx of e raised to 3x is just 3. Move to the next term, where d over dx needs to be distributed among the binomial in the term. So we get d over dx of 1. Then d over dx of arctangent of x. The derivative of 1 is 0, but the other term requires inverse trigonometric differentiation, which states that the derivative of arctangent is 1 over u squared plus 1. We use v for this example as u is already used in the first term. Breaking down the parts, v is x, and the derivative of v now becomes d over dx of x, which is 1. Now place all the terms together. Y prime has a denominator of the square of 1 plus arctangent of x. Its numerator taken as the copied lower term of 1 plus arctan of x, with the derivative of e raised to 3x as e raised to 3x times 3. The second term has e raised to 3x, with the binomial 0 plus the pattern of 1 over x squared plus 1 times 1 from chain rule. Take e raised to 3x with 3 at the very start of the numerator. Then, distribute e raised to 3x among the binomial at the right. Thereby, having y prime as the same denominator and the simplified numerator consisting of 3e raised to 3x with the binomial 1 plus arctangent of x, minus 0 less the fraction e raised to 3x over the square of x plus 1. Simplify the numerator to have a single line of terms, so take the common denominator, which is x squared plus 1. Now convert the whole numerator with this new partial denominator, and get a new numerator with 3e raised to 3x times the binomial 1 plus arctangent of x with another binomial x squared plus 1. Then place minus e raised to 3x. Combine the two denominators to avoid confusion. Y prime then becomes 3e raised to 3x times 1 plus arctangent of x, and again multiplied by another binomial of x squared plus 1 with minus e raised to 3x, all upon the two quantities of x squared plus 1 with the square of 1 plus arctangent of x. Expand a little more to evaluate all terms in the numerator. The term 3e raised to 3x will then be evaluated with x squared and also with 1. Y prime is then the binomial 1 plus arctangent of x multiplied by 3x squared times e raised to 3x added to 3e raised to 3x, then subtract e raised to 3x, all upon the quantity of x squared plus 1 with the square of 1 plus arctangent of x. Now let's try to expand the numerator and see if we can eliminate some terms. Expand the binomials using FOIL method, starting off with 1 times 3x squared e raised to 3x, followed by 1 times 3e raised to 3x. Next is to multiply arctangent of x with 3x squared e raised to 3x. Then also with 3e raised to 3x. Don't forget to place minus e raised to 3x back in the numerator. After the expansion, look for similar terms, where we have positive 3e raised to 3x and negative e raised to 3x. Place them together to come up with the final answer of y prime as the ratio of the long numerator, 3x squared e raised to 3x plus 2 of e raised to 3x plus 3x squared times e raised to 3x arctangent of x plus 3 times e raised to 3x arctan of x, all of which is divided by the quantity x squared plus 1 and the square of 1 plus arctangent of x. This is the final answer.